everyone, it's Mr. Thomas, and what we're going to look at today is using scale. So it's something that features mainly in architectural drawing, but in all other kind of technical drawings as well. So our objective this morning is to look at how we're going to read and apply different drawing scales, and hopefully by the end of this lesson you'll be able to convert sizes using a scale. You'll be able to give examples of both common reduction and enlargement scales. So to start off, the first thing we want you to think about is what scale is. What is it? What does that mean? And where might you use it in everyday life? What does it mean to you? So pause the video and take a wee second to think about that for yourself. And then when you're ready to restart, just unpause the video. So scale can be a number of different things. It could be something to measure weight, so a set of scales that you would step on, or balancing scales that you would put something on each side just to try and equal things out. It could be the skin of a lizard or a fish, which is referred to as scales, or it could be to describe musical notes and how they are arranged. But in terms of graphic communication, what we mean is that scale is a way of changing the size of an object to make it easier to represent, whether that's in a drawing or a model, and we talk a lot about scaling things up and scaling things down. So scales can be used by artists, architects and builders to get an accurate drawing, either smaller or larger than the actual object, the actual subject is. So we have reduction scales, which reduce the size of an object. These can be phrased as 1 to 2, 1 to 5, 1 to 50, 1 to 100, 1 to 250, or 1 to 1250. We also then have enlargement scales, which are things like 2 to 1, 5 to 1. We might sometimes have 10 to 1 and then 50 to 1, but we don't tend to go much bigger than that. So how does a scale work? Well, in a reduction scale, if we take 1 to 2 as an example, for every 1 millimeter in the drawing, it would represent 2 millimeters in the real world. So that allows larger objects to be shrunk down to make it easier for us to draw them. So if you imagine a jumbo jet plane, we can't draw that at full size on paper. It would take thousands and thousands of bits of paper in order for that to work out. So what we do is we apply a scale to reduce the size of the object, so in this case the jumbo jet plane, and by reducing its scale, what we can do is we can put a smaller version of the object. But then what it allows people to do is look at that scale and calculate how big it would actually be. So the example we've given at the bottom is if you were to draw this Boeing 747 at a scale of 1 to 1. Now 1 to 1 is 1 millimeter on the page equaling 1 millimeter in real life. It would actually be 74,250 millimeters in length. So you would need 2,500 pieces of A4 paper just in length, and it would be 18,450 millimeters tall. So you would need 887 pieces of A4 tiled just to get this plane drawn at full size, which obviously isn't practical. You just couldn't do that. So let's now look at an enlargement scale. Now an enlargement scale is when you've got quite a small object and you want to view it bigger. And in this example we've taken a snowflake, something that would be very, very small, something you wouldn't be able to see normally with the naked eye, and you would have to scale it up, you would have to enlarge it. So what it means is a 2 to 1 scale would be 2 millimeters in the drawing would equal 1 millimeter in the real world. And enlargement scales are commonly used for very, very small components, a lot of time for electrical wiring and circuitry, so you can see all the very, very small components maybe in your phone at a bigger size so you can actually understand their shape and dimensions. Now what we've got as the example here is the snowflake above would measure 5 millimeter in width, and it would be very, very difficult to see the level of detail. So what we would do is we would scale it up, and you can see here that this has been scaled up by a scale of 10 to 1 in order for us to see it. What that means is every 10 millimeters in that image actually is only 1 millimeter in real life. So let's look at an example of scale 2 to 1. Now when I look at the scale 2 to 1, I think of it like a fraction. I think of it as 2 over 1. So that's what we're going to do. We're going to basically double the size as we look at this. So looking at the size of the original drawing, the drawing on the left is the normal size, which is scale 1 to 1. Remember, 1 millimeter in the page equaling 1 millimeter in real life. But the drawing on the right is twice the size, and that's because the scale is 2 to 1, so that's 2 over 1. Because the object on the right has been drawn double, 2 times the size of the one on the left. However, you'll notice that the dimensions on it still remain the same. They still remain with the actual 1 to 1 size. So even though we're going to draw it double the size, we actually label it, dimension it with the original sizes, so that anyone looking at the object doesn't then go and manufacture it twice the size. We're only drawing it twice the size to make it a little bit clearer. So what that means is that a 20mm line at a scale of 2:1 is actually drawn as 40mm. The same way that a 70mm line at a scale of 2:1 is drawn at 140mm. So the first task we're going to have you complete is to sketch the same shape, but this time using a reduction scale, a scale of 1:2. So again, treating it like a fraction, 1/2, half. So this means that you are drawing this object half of the original size. So you'd be taking, for example, the 2 centimeters and drawing it at half the original size. Now, use a ruler for it. You don't have to get the angle spot on, it is just a sketch, but we are looking for you to get the sizes accurate. So remember, 1mm on your drawing is going to equal 2mm in the real world, so we're drawing it at half the scale. So the next stage in our lesson is to apply the scales you've been learning about. So you'll need to use this worksheet, which you'll find on your Google Classroom page, and you're going to start applying the reduction scales and the enlargement scales to some household items. So you're going to need to look around your house for some of the items that are shown here, and then you're going to measure them, and then you'll apply those scales, and you're going to add in the correct dimensions to these drawings. There's little boxes already there for you to add into, so it'll ask you for things like the size of your TV in real life, so given a rounded up measurement of your TV, getting the length and the height of it, and then what the scale would be, what size it would be if you drew it at 1:10 scale. So once you've completed these tasks, just make sure that you've submitted it on Google Classroom and turned it into your teacher so that they can give you feedback on it.